Hello student, this is Sir Tutorial Home. I have started differential calculus to discuss. I have already started the limit in my earlier videos. I have already understood all of you what is the definition of limit and how the definition is applicable to its examples, its problems. So some important things that we ignore throughout when we go through any book, but these things should be remembered, and so some competitive exam such kind of area are selected most because students occasionally avoid such kind of things to remember. So I have collected those and I want to share with all of you. So look these important things today which needs to be remembered. First, case 1, if fa does not exist but the limit exists, how it will be understood? If fa does not exist but the limit does exist. I have given an example. Look this example. Limit of x square minus 25 by x minus 5 where x tends to 5. Here fx is x square minus 25 by x minus 5. So you can very easily see that if we put x equal to 5, then there we get the denominator 0, which is undefined. So fa does not exist, means f5 does not exist. f5 is undefined. Here f5 is undefined. But if look the other in the if you want to look the existence of the limit, if it does exist or not, so we need to first check out the left hand limit and right hand limit. So we first put x equal to 5 plus delta 1. 5 plus delta 1, it means x approaches to 5 from the positive side, from the right side. So we put in this function this value x square minus 25 a square minus b square a plus b into a minus b, and put the value of x here. Delta 1 cancels each other and we get 10 plus delta 1. Because delta 1 we choose very small, we can choose very sufficiently small so that we can ignore it, or we can choose so small that we can calculate it abstractly equal to 0. So where the limit goes to now, you can very easily say that the limit goes to 10. It's the right hand limit. And what will be the left hand limit? We will put x equal to 5 minus delta 2. Here in the same procedure we will get 10 minus delta 2. So since the delta 2 is also very small quantity, we can ignore it or we can abstractly take it equal to 0. So the left hand limit is also equal to 0. So both right hand limit and left hand limit equals to 0. So the limit exists. So fa does not exist but the limit exists. Now case 2, fa exists. Here fa exists but the limit doesn't exist. Now take an example. Fx is defined as in such a way that fx is equal to 1 when x greater than 0, is equal to 0 when x is equal to 0, and minus 1 when x less than 0. In such a case, you can see that at the point 0, if you take the right hand limit 0 plus when x greater than 0, 0 plus means 0 just x approaching 0, just right side is equal to 1, and left hand limit where x approaches 0 from the left hand side, it is equal to minus 1. So both sides of the limit are unequal. 1 minus 1, so the limit does not exist. But clearly if we put x equal to 0, it is defined as when x equal to 0, it is 0. So 0 is a finite quantity, it is defined. So the limit does not exist but fa exists. Thank you. We will discuss later the other cases also you have to remember. Thank you. Please subscribe this channel. It is Sir Tutorial Home. And if you have any question about limit, continuity, differentiation, please without hesitation ask me. Thank you very much.